Hello, grade 7, and welcome to the second session of our lesson, which is prime numbers. Let's make this exercise. We have to search for the prime numbers. Is 7 a prime or a composite number? We said that if it has only two divisors, then it is a prime number. If it has more than two divisors or two factors, then it's a composite number. 7 is a prime number, so 12 is a composite number. 41, it's prime. 27, it's composite. 42, it's composite. So the prime numbers are 7, 41, and 11. Okay, now we want to know how to find the divisor of any number. To find it, we have to recall the divisibility rules. We need in this lesson just these four rules. How can I know if a number divisible by 2? How can I know if a number divisible by 3, by 5, and by 10? To know if a number divisible by 2, I have to check the ones digit. The ones digit must be even number. It means the number must start with 0, 2, 4, 6, or 8. If a number is divisible by 3, I have to check the sum of the digits. It means I have to add the digits. If the sum of the digit is divisible by 3, then the number is divisible by 3. To check if a number is divisible by 5, we have just to look at the ones digit. It must be 0 or 5. A number is divisible by 10 if the ones digit is 0. Okay, how to recognize a number if it's a prime number or not? If it is a small number like 3, 5, 7, or 17, we can directly know it's a prime number because it has only two divisors. Now I have this big number, which is 187. I want to recognize if it's a prime number or not. First of all, I have to make for it the divisibility test. Is it divisible by 2? I look at the ones digit. It's not even, so it's not divisible by 2. Is it divisible by 3? I add the digits. 7 plus 8 plus 1, it's 16, which is not divisible by 3. I continue. Is it divisible by 5? I look at the first digit. It's not 0 or 5, so it's not divisible by 5. Look, I'm just testing on the prime numbers, okay? Just on the prime numbers. After 5, I have 7. So let's test. Is 187 divisible by 7? I make the division. The quotient is 26 and there will be a remainder 5. So it's not divisible by 7. After 7 I have 11. 11 is a prime number. 187 divided by 11 will give me 17 and the remainder is 0. So when the remainder is 0, I stop here. Then 187 is divisible by 11. So it's a composite number. So here I stop and I say 187 is not a prime number. Why? Because it is divisible by 11. So the factors of 187 are 1 and 187 and 11. So it's a composite number. Okay, now I have to check if 167 is a prime or composite number. First, as we said, I have to check if it's divisible by 2, 3, or 5 because I know the rules of 2, 3, and 5. Let's check if it is divisible by 2, 3, or 5. Is it divisible by 2? It's not divisible by 2 because the ones digit is not even. Is it divisible by 3? Let's add the digits. 7 plus 6 plus 1 give me 14, which is not divisible by 3. Let's check if it is divisible by 5. The one's digit is 0, not 0 or 5, so it's not divisible by 5. So now I have to check if it is divisible by 7. Okay, so now I continue checking if 167 divisible by 7. 167 divided by 7, the quotient is 23, and I will get 6 as a remainder. So it's not divisible by 7. I continue to the next prime number, which is what? Which is 11. Now I have to divide by 11. 167 divided by 11 will give me 15, and the remainder is 2. So 167 is not divisible by 11. I continue to the next prime number, which is 13. Don't forget, I'm here to know if 167 is prime or not. If it is divisible by 7, 11, or 13, or 2, or 3, or 5, or 7, then it's not prime. Okay, so I'm now continue dividing because till now there are remainders. 167 divided by 13, the quotient is 12 and the remainder is 11. So it's not divisible by 13. But look here. Compare each divisor and its related quotient. Look at the divisor and the quotient here, the divisor and the quotient here, and this one. What do you notice? In each case, the divisor is greater than the quotient. Okay, we noticed that while dividing it by 7 and by 11, the quotient was bigger than the divisor. While when I divide it by 13, the quotient is less than the divisor. So I stop here. When the quotient is less than the divisor, I stop dividing, and we say 167 is a prime number. I will repeat. First, I check if 167 is divisible by 2, 3, or 5. Then I check if it is divisible by 7. I divide it. There are a remainder. There is a remainder. Then I divide it by 11. Also there is a remainder. But I continue dividing it. Why? Because the quotient was bigger than the divisor. I then divide it by 13. There is also a remainder, but the quotient was less than the divisor. So I stop dividing, and therefore 167 is a prime number. Okay? So the rule says that how to recognize if a number is prime or not. First, we divide it successively by 2, 3, 5. I know the divisibility rules, and continue by 7, 11, 13. Only prime numbers. If there are no remainders, I stop. If no remainder, and then it is a composite number, just like the first example. And if there is a remainder, I continue. When the quotient will be less than or equal the divisor, I stop and I say this is a prime number. Okay? Thank you for watching, and this is the end of session 2.